All right, where we left off with the previous video was talking about noble gas configurations. Okay, and noble gas configurations were basically like a shorthand version of a normal electron configuration. And what you want to do there is find the noble gas in the row above the element you're after, and then just list what's in the same row as your element. So if I wanted to do the noble gas configuration of chlorine, okay, I'm going to look in the row above and find that my noble gas is neon. So my noble gas configuration for chlorine starts with neon, and then I just list the things that are in the same row as my element, which is chlorine here. So reading left to right, I go 3s2 is at magnesium. Then I continue across until I get to chlorine is at 3p5. Okay, it's much, much shorter. All right, so things to remember when doing larger atoms is that from period 4 and below, D block drop down a number. Okay, and then for F block, we drop down 2 numbers. Right, and then still just reading left to right, which is still important. Okay, because the order in which things fill is important. Okay, so we already did germanium. Right, so remember, germanium was sitting right here at element 32. And the noble gas above it is argon. And we read across, so let's put germanium up here. So it was argon, and then I just list what's in that row with germanium. And I go 4s2. And then when I hit the D block, I have to drop down a number. And I say 3D. And we read across, and we get to a D10, so we list the D10. Right, and then I read across, and I'm back in the P's, so when I get back to the P's, I go back up to 4, and it's 4p2. Right, so let's do another one. Right, let's do the noble gas configuration for iodine. Right, so my noble gas above iodine is krypton. And then I just read across in the row that my element is in, which is row 5. So I go 5s2. And when I hit the D block, I have to drop down a number, so now I'm at 4D. And I read across and I get to D10. And I keep reading across. When I get to the P's, I'm back up to 5. And iodine lives at 5p5. All right, let's do one more. Let's do lead. Way down here, element 82. All right, so my noble gas above lead is xenon. All right, so I'm in row 6. So I go 6s1, 6s2, and I list it. Okay, and here's where I hit the F block. Okay, the F block starts at the lanthanides and actinides. Right, so I'm going to drop down to my F block, and I drop down 2 numbers when I hit the F block. So now I'm at 4F. And I read across, and I get to the end at 4F14. Right, and then once I hit the end of the F block, then I come back up, and I'm sitting back here in the D block, and I'm at 5D, and I keep reading across, and I get to 5D10. And lead is at, when I get back to the P's, I'm back to 6, and lead is at 6P2. All right, so now that we've got a handle on how to do the standard electron configurations, let's talk about exceptions. Okay, exceptions to the normal electron configurations are chromium, molybdenum, copper, and silver. All right, so let's do the electron configuration for chromium. All right, the normal electron configuration as we have been discussing it. So the noble gas above chromium is argon. And then we're in row 4, so we would have 4s2, 3d4. Right, so, but here's the thing, is that half full D is more stable. Right, so that would be a D5. Right, so what it does is it borrows from the S. Right, so what we end up with, the correct electron configuration is argon, 4s1, 3d5. Right, molybdenum does the same thing. So it would be an S1D5 for molybdenum. Right, so your exceptions live at D4 and D9. Right, so let's take a look at what a D9 one likes to do. Right, so let's look at the electron configuration for copper. All right, the normal version, as we've been learning, four S2, 3D9. Right? But just like with half full, totally full is more stable. In other words, a D10. Right? So it's going to do the same thing. It's going to borrow from its s orbital so it would be a 4s1, 3d10. Right? So in order to get to D5 or D10, it's going to borrow one electron from its s orbital in order to get to the half full or completely full state. Right, so silver and copper both do the same thing. They'll do a 4s1, or excuse me, just s1d10. And then copper and molybdenum do an s1d5. Right, so those are your exceptions to the normal version of the electron configurations. Now, it's important to know that if we're at D6, it does not lose a D electron in order to get to D5. Okay, because I can't put it anywhere. There's nowhere for that extra, that D6. There's nowhere for me to put that extra D electron because the s orbital can't hold any more than 2. I'll never have an s3. That's not physically possible. Okay, so if I get past D5, it just is what it is. Okay, but when it can promote something from a different level and move things around, sure, it'll promote to D5 or D10. All right, so let's talk about electron configurations of ions. All right, so cations, we remove electrons. Okay, and we remove from the highest energy orbital first. All right, and I suppose I could start writing down below here, actually. Let's do that, so I'm not cramping in so much. All right, so cations remove electrons from highest energy first. Anions, we add electrons. All right, so let's take a look at a few examples of how that sort of plays out. So let's look at aluminum. Right, so the neutral electron configuration for aluminum is neon, 3s2, 3p1. And I want to encourage everyone to start with a neutral configuration. All right, it's really easy to try and eyeball things and just say, oh, it's such and such. It's really useful to start with a neutral electron configuration and write it out, and then you can see how things come off. All right, so let's look at what happens when we go to aluminum plus. All right, I'm going to remove electrons from the highest energy orbital first. Okay, and that would be my 3p. All right, so aluminum 1 plus is neon 3s2. All right, so we just take an electron off of that p orbital, and there was only one to begin with, so that removes the p. Aluminum 2 plus, now my 3s is the highest energy orbital, so that just becomes 3s1. And then my aluminum 3 plus is just neon. Okay, and the electron configuration for neon, 1s2, 2s2, 2p6. Right, so the most common ion that aluminum forms, aluminum 3 plus, has the same electron configuration as a noble gas. Right, and this in fact is why elements form the ions that they do, in order to have the same electron configuration as a noble gas, because that's a particularly stable place to be. All right, we're going to go ahead and stop this video here, and we'll pick it up on the next video talking about configurations of anions.